only then you will be able to understand what electricity is. Let's talk about those terms, which are first term is current. Then you will have a voltage, right? The other name of this one is potential difference. And there is another name for that, that is electromotive force. Okay. Now, one by one, let's discuss them. First of all, current. Now, what is current?
Current is the rate of flow of electrons.
Yeah, it's a rate of flow of electrons, which everyone knows. Rate of flow of electrons. We know that. But, in books, in our IGCSEs or in even A levels, there is another definition for that, that is rate of flow of charges, or you can say positive charges. Can you tell me why is this? Why is that the case?
Um, because they carry charge.
Okay, now I'll let you know.
Because
Actually, I'll explain. Initially, when that classic physics was actually came into being, or you can say when actually scientists started working on this all, at that time electron wasn't discovered. All right, so they were thinking that it's not electron which is actually flowing in the circuit, but it's positive charges, or you can say protons, which are actually flowing into the circuit. So initially, the definition of electron was flow of positive charges, or you can say flow of protons. All right. You know, After some time, when electron was discovered, we can't say that the old scientists who worked at that time was totally wrong. So what do? We say, okay, let's keep up with the whatever they said it. So we actually have two categories of current. One current is called a conventional current, and the other one is called actual current, which we have it and we give it a name called electronic current. Now, what is electronic current? This is the rate of flow of electrons. And what is conventional current? This is the rate of flow of charges. And why we use it? We use it as a sign convention. This current actually doesn't exist. Remember that, because there is no flow of positive charges. It's always the flow of electrons, but it's just for the sign convention. Whenever you see a battery, this is a battery sign. Which one is a positive side and which one is a negative side?
the long side.
You always see a battery and you will always see a current sign from positive to negative. Always. It's shown from positive to negative in the battery. It's never shown from negative to positive because they always use the sign convention for the conventional pump. By doing that, actually, our calculation doesn't affect it. It's all calculation as we have done previously. But only thing is, we adopted their sign convention because they are the one who started this all. So remember that now there are two type of current. We have it conventional and electronic current. Whatever calculation we are doing on the basis of conventional current, not on the basis of electronic current. That's the reason while we are doing calculation, we always take current from positive to negative rather than taking from negative to positive. All right. Now,
Right.
understood everyone? Yes, Zoha?
Yes.
Okay. Now, the mathematical definition will be I is equal to Q upon T. Q is a charge, T is a time. What is the unit of charge?
Um, unit of charge is coulombs.
Coulombs. So technically, the unit of current will be coulombs per second. All right. So your
Right.
unit for the current is coulombs per second. The point is, if current unit is coulombs per second, where this ampere comes from? Because SI unit or standard international unit is international unit by which current is actually recognized as that standard international unit of current is amperes. You know why? The reason is because I is equal to Q upon T, that is coulombs per second, is firstly discovered by a scientist named Ampere. So he give it name coulombs per second as Ampere.
Okay.
So we don't call it coulombs per second anymore. We called it Ampere. But we know that Ampere is equal to coulombs per second. All right. Just a,
Right.
just a second. Okay. Everybody understood what current is?
Yes.
Yeah.
Okay. Now let's move on. Let's move on to a big name, voltage. There is another name of electromotive force, and there is another name of, you call it, potential difference. And every name has certain, significance. And because you are in A level, so I can say that these three things are different. At least voltage and potential are different from each other at certain point. When we will be actually talking about the internal resistance and lost voltage, then they will be different. Otherwise, they are normally considered to be the same. Okay. So there is a
Okay.
small difference. When we come to that, I will definitely discuss with you. For the time being, let's discuss the definition of this voltage one by one on basis of electromotive force, potential difference, and voltage. Let's talk about electromotive force. Now, as the name suggests, electromotive force, it means that it is some kind of force that is pushing electron into the circuit. Am I right?
Yeah.
So basically, let's take an analogous example. Okay. Let's take an example of a building, which you have it, for example, it's a six-floor building. And you need to pull the water at the sixth floor. How do you do this?
A pump.
A pump. Absolutely right. Now let's have a power of a pump. You got a you got a pump available 400 horsepower. You got 600 horsepower, and you got 700 horsepower pump. Which pump you prefer to buy to lift the water to the sixth floor? 401,
The,
601, 701.
the 701
Can you tell me the reason why?
because it's more powerful.
And by using this power, what actually the pump will do? Actually, you
Uh,
need more water to be pumped upstairs. Am I right?
right.
So basically, what your pump is doing, your pump provide a strong pumping force if you take more horsepower. So there are two things this pump is doing. One, more pressure and more water. Am I right?
Right.
Now take the same thing here. If you have a battery of 6 volts, 7 volts, and 10 volts, if you take this battery provide more pressure or more pumping force to the electron to go into the circuit. Am I right?
Yeah.
And secondly, more charges will be flown into the circuit. It gives more charges to the circuit. So basically, now what is meant by electromotive force? It is a pumping force which provides, it is a pumping force which pump the electrons from one point to another in the circuit. Understand?
Right.
Okay. So once you understand that, okay, now the point is, once you understand this, It means that more voltage means more pumping force, less voltage means less pumping force, and less charge. Now, my point is, I'm asking a very interesting question. Can you use the battery which is used in the car at your home, even though the voltages are same?
I know this one.
Yes.
You cannot. You cannot
The reason?
because the the battery powering the home is AC current and the one powering the car is DC current.
No, 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 no. It's not about DC and AC. Only thing is the battery which is used in the car is a big battery. It provides more charges. If you try to use that thing in your home, I tell you, your device, whatever device you are connecting it with, it will be blast. That battery provides more pumping power, and more pumping power means more charges. More charges means the charges which are not actually adequate for that, or you can say the charges which are there, it's not that much charges required. So if you try to
Okay.
connect with the car battery, for example, your home appliance, you're you are at risk. And same thing happens. You cannot use any particular battery into the car except the car battery. Reason is you need very much high power, high pressure, or you can say uh, high charges. So for that reason, that battery which is used in the car is appropriate. Understood?
Yes.
Good. What about you, Alicia?
Yeah.
Hello. Okay. Now, once you understand that this is a small concept, now let's start with the voltage. Now, by using voltage, mathematical definition is it's a work done in moving the charges from one place to another in the circuit. So mathematical in the circuit. So mathematically, if you call it V, that will be equal to work done divided by charges. So what is work done? The unit of a work done?
Joules.
Joules. And charges are coulombs. So the unit becomes joules per coulomb. Now again, the scientist who discovered this voltage, his name was volts. So he gave his name to that particular physical quantity. He said it's a volts. So unit of joules per coulomb is volts.
Okay.
Okay. So we have discussed voltage, we have discussed electromotive force. Now the last thing, the name is potential difference. This is a very small concept which I have to give you here. Why we call it potential difference? You have this straight, smooth ground. You actually threw a bottle of water here. My question is, water is here, right? Will it flow or not? Yes. What do you think? Will it flow or will it not?
I know the answer to this one, but it would be no fun if I said it.
So water will definitely not flow. The reason is very simple, because the water is at same potential. Same potential means height will be same for all the water. To flow this one, we need a sort of a difference of height. If you throw a water from here, it will flow down like that. So you need a difference of height, or in other words, you need a potential difference. If you do not have a potential difference or difference of height, water cannot be flown. So actually, it's the same thing happen in the heat. My question is, if you're something you actually put it, let's take an example of a cup of tea, a hot cup of tea. You place it somewhere in the open air. What will happen? Yes, Zoha and Alicia.
Say it again.
My question is, if you put a hot cup of water or hot cup of milk or whatever, placed it in an open air, what will happen?
It will cool
It
down.
evaporates.
Actually, the heat comes out of it, and heat will come out until this cup of water temperature will be equivalent to the room temperature. Am I right?
Yeah.
The question is, why not its temperature will be reduced from the room temperature once it's reached to the room temperature?
Hmm.
Because if, for example, heat is coming out continuously, then why not once it's reached to the room temperature? Do you ever see water freeze to ice by on without, I mean, having putting in into the fridge? Is it possible?
No.
But why not? My question is this. Because what we seen is that when you place a hot cup of water, after some time it was cold. But after become it was cold, right? When it was at room temperature, I never see water reduce its temperature from the room temperature. Why is that so?
Because there's no work done
Why there is no
to
work done? That's
make
my
it
question.
colder.
You're absolutely right. There is no work done. But why?
Uh, I'm. I think it's because of the electron movement and stuff, but I think I'm making it complicated.
No, 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 no. I tell you. Today I will open up your mind, hopefully. Don't worry. See, the reason is very simple. Remember that heat is a special kind of thing which transfer from body of higher temperature to the body of lower temperature due to temperature difference. Until there is a temperature difference, heat will be transferred. As soon as there is no temperature difference, no heat will be transferred. So when that particular cup of tea or whatever it is, when it reaches to the room temperature, the temperature difference gonna be finished. And when the difference will be finished, there will be no heat transfer. It's the same thing as a potential difference. When both are at the same potential, no heat will be transferred. Same thing applies to the potential difference, that when you throw a water here, because all the flow is at same potential difference, so no water will be flown. But as soon as you create a potential difference, water start flowing. Same thing happen in the battery. Your positive side is at different potential. Your negative side will be at different potential. And because of this difference, the electron will flow into the circuit. If this potential difference is not there, then there will be no current inside the battery. Understood?
Yes.
Yes.
Or any question? If you have any question, let me know.
No, this is fine.
Good. Once you understand this, now another small concept, because once you understand that, I'm continuously using a term circuit. Can somebody tell me what is meant by circuit?
Uh, a
Yes,
cycle.
cycle. What do you mean by cycle?
A cycle. Um. Uh. Actually, I'm not sure.
No problem. First of all, the first point in a circuit is it's a closed path. Remember that if it's not a closed path, it will not be a circuit. If it's open path, it will not be a circuit. It should be a closed path, okay? If it's not a closed path, no circuit. Now, this closed path comprises of following equipments. Now, what are these equipments? Let's see one by one. First equipment is your source, or you can say battery. You should have a battery which should provide the electricity If the battery is not available, then maybe or maybe not, actually, it will not be a circuit because circuit needs current or a voltage source. So first thing is this pass must comprises of source or a battery. Second is different type of electrical appliances like TV, fridge, microwave, bulb, resistance, whatever it is. Third thing is wires. Sometimes we called it interconnectives. Can you tell me there are fourth type of wire, appliance as well, which are used? Can you name it? What is it?
Wait, what do you mean? Say it again.
My point is there are different equipments, right? Source
Mm.
or a battery are in the circuit, appliances are available in the circuit, wires are there in the circuit. There are fourth type of equipments or appliances which are a part of a circuit as well. Can you tell me the name of those appliances? A type of appliance?
A switch?
What is this? You are absolutely right. I'm not asking you told me a specific name. Now, what is that switch device is?
A
You're right.
component?
You can call it uh, safety devices. Safety devices. Safety and control, you can say. These are the devices which are used to control or, safety of the circuit. So that is the first thing which is important about the circuits. Okay. So now if somebody will ask you what is circuit, you will tell him or her this definition that your circuit comprises of a closed path and that closed path must comprises of these equipments. If these equipments are not there, definitely even if one or two of them are available, it is a circuit. But source or a battery should be there. If no source or a battery, then you don't call that circuit as a circuit. All right?
All right.
What falls under safety devices like switches, like she said, and resistors? Do they fall under it
No, no,
as
no, no,
well
no.
or no?
I tell you, switches, fuses,
Okay.
circuit breakers. I will show you. Let me just show you through the internet. What are these devices? You ask me, so I will definitely give you an answer for this. Check it out. This is a called fuse and circuit breaker. Now, check it out. You must see that somewhere in your house because everywhere in all the devices, you might see these kind of things. Do you ever see this device? Wait, that one. This is called fuse. That one.
Mm.
This is a device or this is a equipment or a component. Normally, it is placed in every single a high current taking devices. Can you tell me the name of those devices which are taking high current or too much current in your house?
Anything that is used for heating,
Can you give
like
me the name?
hair dryers,
Hair dryer is not that.
kettles,
You can say
fridge
iron
wash,
is the one. Iron is the one. Microwave
I-
and air condition. Because they are
does
take. Yeah, well, you're saying something?
a fridge?
Not fridge. Fridge is not taking too much current. Your devices which are taking too much current is normally based on motors. Remember that. Whichever device using a motor, it takes too much current. Air condition is the one. Microwave is the one. Washing machine is the one. What do you call it? Hair dryer is not the one actually. And iron is the one. So these are the devices which take too much current. And because they are so much expensive, so what do? We put this kind of fuse inside it. Because suddenly what happens sometime it takes too much current. That current it takes will be more than it required. So what happened? These fuses will break when it takes extra large current. So their value will break those and your device will be safe because you cannot reuse them again and again. I will explain this fuse when the time will come. We have this topic in our course. And you may see these circuit breakers. Do you ever see these in your house?
I
The,
have seen the circuit breaker. I've not seen a fuse.
Now I want you to, once the class will finish, I want you to see they are normally placed in the main circuit, main circuit of your house. What is the good thing about circuit breaker is that due to some reason, if suddenly extra large current comes to your house, these circuit breakers will turn off. After some time, you can turn it on and you will have your you will have your current once again. So basically,
Yeah.
these are placed in your houses. So these are safety devices. We call them safety devices in special category. They are not there in all the circuits, but they are there.
Mm.
Okay, understood?
Yeah.
Yeah.
Okay. Now, once you understand that, now let's see the things one by one. First of all, let's see the relationship between the voltage and the current, which we are on at the moment. Okay, wait a second. What is coming up? Okay, we are here, right? So basically, now the thing is, let's talk about this. Now, what is the relationship between the voltage and the current? That's what our important topic is for now. Can you tell me what is voltage and current relationship?
There are two ways you can have power equals to current times voltage and
No, 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 no. I'm
um
asking about the relationship between voltage and current.
Is it
Directly,
directly proportional?
it is directly proportional.
oh yeah.
So
Oops.
basically, you will say that now this is very interesting law, and we called it Ohm's law. We will focus. We may take some time on explaining this Ohm's law because there are so many things in it. We say that voltage is directly proportional to the current passing through the conductor. Remember that when I use the word conductor, don't be confused. This means a wire. Okay. Provided all the physical conditions remain unchanged. Now, this is very interesting actually. They say that voltage is directly proportional to current. First of all, remove this directly proportional sign, you will have a constant multiplier here, that is R. And what is this R? This is called
Resistance.
resistance. So technically speaking, voltage is directly proportional to the current at constant resistance. So resistance is not changed in this case. Now, what is resistance? Anyone have any idea?
Resistance is how hard it is for charge to flow.
Basically, it is the opposition offered by the material to the flow of current through it. So it is the opposition offered by the material to the flow of current through it, right? How much
Right.
opposition it is offered. And again, what is the unit now? If you say R is equal to V upon I, then voltage is equal to how much? Volts, and current is equal
Yeah.
to ampere, right? So volts per ampere. Again, the scientist who actually discovered this relationship, his name was Ohms. So he gave it a name, resistance, as ohms. So the unit
Mm,
of resistance is ohms. This is a sign.
okay.
All right.
Right.
Alicia,
Yeah.
you?
Yeah, I understand.
Good. Now there are
Um,
few things. Yeah, you're saying something?
when you wrote the definition for voltage is directly proportional to current, what did you write when you where it says physical something?
Yeah, I'm coming to this. Now, this is what the
No, I
point is.
cannot read.
Okay, I'll read it. Voltage is directly proportional to the current passing through the conductor, provided all the physical conditions remain unchanged. All right.
Okay.
Now, what is this thing? Provided all the physical conditions remain unchanged. This is very interesting point. What do you mean by physical condition, first of all? Let's suppose you are doing this experiment with a wire, right? Let's suppose this is a wire. You have certain equipments here, and you're doing it at a room temperature. Let's take it an example. Let's change this device now. And now you do the experiment once again. What do you think? Will your result be the same as the previous one?
No.
Now you
Yeah.
no, it will not. The reason is you change the devices. If you change the wire, you may have different results.
Yes.
Okay. If you change the what you call it, the position or the area where you used to do that experiment, you may have different results.
Mm.
If you change the temperature other than the room temperature, your result will differ. But now listen to me, 95 or 96%, even more than that, when you're saying provided physical conditions remain unchanged, physical condition means, can anybody tell me what do you mean by physical condition 96 or 99%?
Temperature?
Temperature. So basically, you're talking about temperature because temperature is the one which is changing all the time. I can give you a reason. You tell me if you turn on your device for certain period of time continuously, after some time, 1 hour, 2 hour, 3 hour, when you touch the divider, what do you feel?
It's hot.
It's hot. What do you think? The temperature rises?
Yes.
If temperature rises, your V and I relationship will not be the one when you started the experiment. So always remember in V and I relationship experiment that temperature is the key. You will never have all the time the same relationship which you have it. So this temperature should be kept the same so that you will get the results that you are expecting. I will tell you what kind of result you will get it as we proceed further. So physical condition generally means temperature. All right? Everyone
Okay.
understood?
Yes.
I'm very slowly going so that you understand the basic concept of this. And I'm going in a proper way so that everything comes to you one by one. It's a sort of a movie. Every single scene comes over another scene, and then other scene comes right another scene after another scene. Okay. So if you go by, through proper channel, you will understand everything. Wherever you stuck, let me know. Okay.
Okay.
Now, important point. If you understand that temperature is the one, now let's see some resistance. On the basis of resistance, there are some points which we have to discuss. When I say resistance is kept constant, we need to see which objects have more resistance, which objects has mediocre resistance, and which objects showing very less resistance. For that reason, we categorize our material into conductors, and the other one is, can you tell me other one? The name of other material?
Meters.
Insulators?
Insulators. So
Can I
conductor,
say something?
yeah, please.
You will also teach about semiconductors.
Semiconductors are one as well, but semiconductor are actually derived, or you can say are formed by the conductors. There is a reason to form semiconductor because we want to control the electricity. Again, the same thing. For the time being, I'm just giving you an example of conductor and insulator. I will provide you the definition and the example of semiconductor as well. You are absolutely right that there are devices which are semiconductor devices as well. Just give me few minutes, then I will also discuss you. I will also discuss the semiconductor wave. But these are the devices which conduct or which do not conduct. Okay,
Okay.
I will discuss. Don't worry about this. First one, conductors. Now, conductors are divided into two. One is good conductors, and the other one is bad conductors. These are all what we are talking about electric insulators and electric conductor. Remember that. Why I am saying electric? Because you have thermal conductors as well. Thermal means heat. They conduct heat or they do not conduct heat. Okay.
Okay.
Now my point is when there are two type of conductors, good or bad, how do you differentiate between a good conductor and a bad conductor? One give the facility to current to flow through them too much, and one give less facility to conduct the current through them. Am I right?
Yeah.
So the point is, that can you give me any example who is a good conductor? Any particular material
Um,
name?
Copper.
No, copper is a bad conductor technically.
What?
Yes,
Oh,
iron. Now you are confused
iron.
at this point, right? Because everyone is saying copper wire, copper wire, copper wire. Am I right?
Right.
So why I'm saying copper is a bad conductor? A very simple reason. Which wire and where do you use the copper wire? First of all, tell me.
In circuits.
No. Now today, what you do? Go home. I don't know how you can do that or not. Bob your wire, which is actually there and here. You will find out that the wire is actually an iron wire. Copper wire mostly used in telephones, telephonic wire.
Oh,
I'm not saying that they are not conducting current. Did I say that?
no.
They conduct electricity, but in less quantity. But if you really want a what you call it a wire that conducts most of the electricity, they are electric wires. A proper electric wire, which is normally of red color, that wire is made of iron. On the top, you will have a plastic coating or an insulation. But the copper wire or a pure copper wire is actually the wire which is made of what you call it telephonic wire.
You
You
know,
know,
that actually makes sense because there are fairy lights and you can touch the copper even though
absolutely. Yeah.
there's
You
charge
know,
running through it.
and I tell you one thing, in copper wire, you will have a current. If you have a M meter and you will check the current value, you will find current, but it's in milliampere. That's why when you even touch it, you don't care. It will not affect you. But the same thing, can you do it with the proper, that devices which are used in your main supplies? Can you do that?
No.
You cannot because there is too much current in them and they are proper iron wire. Now, I am telling you a very interesting fact now. Actually, you are not even using the good conductor wire or a pure iron wire in your main circuit as well. You use an alloy wire. You know what is alloy?
Yes.
This is a
It
mixture
consists
of,
of more
yeah. So actually what you do, you put some of the impurities from maybe bad conductor, some with a good conductor, and you made a proper material through which, I mean, these are the wires you are used as a normal electric wire. All right. So you're not using pure iron or pure copper wire. You use mixture of these things, even in telephonic wire or even in what you call it in electric wire, main circuits. Now you understood, everyone?
Yeah.
Any questions?
Yes.
But our
No.
elders, our parents, the people who are elder, they normally called we are going to buy copper wire. You never heard that there is iron wire because it's in their mind that all the wires are made of copper. Okay. And one more important thing is even the iron wire is not pure iron wire. It's a mixture of some copper, some iron, some maybe steel, some maybe other. So they made it an alloy. Okay. So that is the thing. Even the pure copper wire is not the pure copper wire, but maybe there is a high percentage of copper in that. Can you tell me why they use alloy rather than the pure good conductor or a bad conductor?
It's cheaper.
No, how can it be cheaper? If you made a wire of alloy, a mixture of different material, how can that be cheaper? That will be expensive technically. You know, the reason
Oh,
is good conductor wire, you cannot control the flow of current. When you want certain wire that it must have some characteristic of a good conductor, some characteristic of a bad conductor, it will conduct this much particular current, this much not. So you have to make certain wires or certain material wires which actually conduct that much amount of current. You understand? It's a sort of a controlling in your hand.
yes.
So it will be a bit expensive wires. Okay. Understood? Shall we move on?
Y- Yeah.
Mm.
Now, now the second wire is called insulator. Insulator is purely a device which do not conduct any electricity. Alas, no electricity passing through it. Can you tell me any example of it?
Rubber.
Wood, rubber, these are pure insulator. Wall is an insulator. So this is not used anywhere.
They're,
They are not
they're
used.
good and bad.
No, insulator is not good or bad. Insulator is an insulator.
Okay.
They are just used to, most of the time, they are used to segregate two electric devices sometimes because we know that it will not conduct. Right? Like there are two wires and you want to segregate so that they will not touch each other. So what we do, we segregate them by using an insulator between. Now you're telling me or you're asking me a question few minutes ago, semiconductors. The question is conductors. In general, now I'm talking about conductor is a device that conduct electricity. Did I say that?
Yes.
The question is, did I say that on certain temperature it will behave as a conductor, at a certain temperature it will behave as an insulator? Did I say that?
No.
So actually what you are doing now in semiconductor, they have some characteristics of conductor and some characteristics of insulator on the basis of the temperature or on the basis of different situations. So by doing that, you will have a proper full-fledged control in your hand that on what particular condition it will behave as an insulator, that it will not allow any current passing through it. On a certain temperature, it will allow current to pass through it. Understood?
Yes.
So that is what we called as semiconductor. And semiconductor is actually made by putting impurities in different kind of devices because this is not in our course, so I'm not going in detail about that. But remember that semiconductor have some qualities of good conductors or bad conductors and some quantities of insulate. We can use it as per our demand. Like
Wait, you said that semiconductors are not in our course?
semiconductors P and N types transistors. I don't think so. Or is it in our course?
But I think we learned it in school.
Yeah,
Did you?
you must be teaching English AQA. We do Oxford AQA, so it is in our course.
Is it? Might be. What
Yeah,
is the topic? What can you tell me the topic name? Maybe what about transistor diodes and all these? Is it in our course?
transistors, diodes. Wait, transistors as in.
Because as far as my knowledge is concerned, diode is in our course as far as VI characteristics are. But in details of how do they function, What are the values? I don't think so.
No, not in detail.
That's what I'm saying. But if you want it, I will tell you semiconductor in detail. But for the time being, let's move on because they are a separate part. Okay. In the end,
No,
once
the only thing that comes up for semiconductors specifically is they ask a question, the definition of a semiconductor.
yeah. So semiconductor, okay, I will let you know. Semiconductor is simple a device which having a characteristic of a conductor and an insulator at the same time. And definitely those characteristics are on different temperatures. On some temperature, they behave as a conductor. On some temperature, they behave as an insulator. And how do we made them? We made them putting some impurities into the conductor. That is what we called as semiconductor devices. Understood?
Hmm.
Okay. Now let's move further, which actually I wanted to. Sorry. Okay. Now we were on, where were we? We were on Ohm's law. Once again, now let's find out the relationship between voltage and current once again, which we are at the moment. We call that relationship, and we can actually discuss this relationship in the form of VI graphs. This is very important, VI graph. VI graph means voltage current graphs, or we can call it voltage current characteristics. Now, what is it actually? We will put voltage at x-axis and current on y-axis. How do you expect the graph should be?
One straight line.
One straight line. Absolutely right. Because the straight line shows that V and I have a direct relationship. All right.
Right.
But point is it necessary that it is always a straight line?
No.
Then what happened?
When it becomes non-ohmic.
Now, very, very important point. What if the graph value is like this? At some point, it's a straight line, and then it will become a curve. How do you discuss this, or how do you explain that?
That
There's
could
a
be a
change in physical conditions.
Actually, what happened till this point, where you will get a straight line, the temperature was same. Temperature wasn't changed. But as soon as the temperature changed, your graph will become a curve. And there will be no more directly relationship between the voltage and the current. So this is the pure characteristic of voltage and current. It shows the direct relationship between voltage and current at constant temperature and resistance. If you see here, if I write the characteristic of that, I can say that this graph shows direct relationship between current and voltage at constant temperature. At constant temperature, let's take this point as O. Till point O. So what happened after point O?
The graph curved.
No, I mean definitely the graph curve, but practically what is happening after 2?
The resistance became inconsistent.
Or
The
you can,
temperature changed.
yeah, temperature actually changed. you can say. At point O, the temperature changes. So the resistance of the component changes, and V and I are no more in a direct relationship. Zoha and Alicia, do you understand that?
Yes.
Yeah.
Any confusion, please ask. Whatever till now, whatever we have studied, if you have any confusion, I give you 5 minutes to just quickly go through. And if anybody have any question, you can ask, because now we will proceed further in this. Because now from here on, I will let you know the one more quantity that is called as resistivity, and then I will take you to our other small topic, which is related to VI characteristics of different kind of components. So just quickly see through. If you have any question till now, you can ask.
This is fine. This is GCSE stuff.
Right?
Hmm.
We have to actually go through this all to actually go to our main topic, because this is, I normally, as a teacher, we normally do not discuss in that much detail these topics. But with you, because you are a A-level student, so I have to tell you this temperature thing. Normally, we do not say in detail about this temperature, that this graph is at constant temperature and this graph is at different temperature. Normally, we do not, because they do not care what temperature is, but here we have to, right? So now, important thing. Wait a second. Now, a new quantity we have to discuss, but before that, there is a thing which we have to discuss is called as, like, factors affecting the resistor. Factors affecting the resistor. Yeah, resistance. Can you tell me what are the factors affecting the resistance? One is temperature, we already have discussed. Okay. What other effects?
The length of the wire and the area.
Of course, directly relation is the length, and inversely relation is the area. If length increases, resistance increases. If area reduces, length increases. Or if area increases, resistance reduces. So when you combine these two, it will be R directly proportional to L upon A. So R equal to rho L upon A. This is called resistivity. How do we explain this resistivity? R A upon L. R is R. A is, let's suppose, meter square. This is meter. So technically speaking, ohm meter. This is what your resistance is. So how do you explain this resistivity now?
Mm,
Ohm meter.
yes, but I'm not sure actually the definition.
See, it means that resistance of 1 meter of a wire, or 1 centimeter of a wire, or 2 centimeter of a wire. It depends what is constant. Because what we believe is that resistance of 1 meter wire or 1 centimeter wire, if you know that, you can simply multiply it with 10 and you will get the resistance of 10 centimeter of a wire. So this is a constant. You can say resistivity means 1 meter of a wire resistance, or 10 meter of a wire resistance, or 5 meter of a wire resistance, depending upon. Okay. So this is a new constant, and that can be formed if the area, length, or the resistance will be given to you. All
Okay.
right. Any question?
Mm, no.
Remember,
No.
girls, remember that, because this is the basics. That's why we have to go through that. Once you understand this all, then definitely I will take you to the major course of this particular thing. Now, at this point, there are few symbols you need to know. So, electric symbols. I'm making symbols. Let me know what are these. What is that symbol?
Lamp,
That is bulb, right?
bulb,
What about this?
resistor,
And you also see this particular sign as well sometimes. So it is resistors or resistance. Remember that resistance normally means you're talking about some equipments, maybe microwave or something like this. All right. Then you have this one. What is this?
uh, ammeter.
And what is ammeter?
It measures the current.
Okay. What about this?
Voltmeter.
Voltmeter,
Voltmeter. Okay. Voltmeter, ammeter. What about this sign?
cell,
It's a battery, right? What
mm,
about this?
Light
very,
dependent resistor.
No, this is called a variable resistor.
yeah,
Oh. Light dependent has two arrows or
I will let you know. Will.
oh,
Light
the
dependent is this.
has a circle and two arrows
Yeah,
pointing.
like this. If you want to put a circle, you can do that, but sometimes you will leave it like this, or sometimes you put a circle with two arrows. LDR. Okay. Okay. These are the devices which are actually used. You can have more than that. What about this?
Switch,
It's a what is this position called? This is
position,
this is called
open,
open switch. And if I place it like this is called closed switch.
closed.
Right?
Mm,
Understood everything? Symbols, everything?
yes.
yeah.
Good. If you understood all this, now we will proceed with this. Let's talk about ammeter quickly. You said ammeter is a device which is used to measure current. At this point, I will say something new which is absolutely new for you. You never heard this in your life. Actual device which is measuring the current is not an ammeter.
It's not.
Actual device is called a galvanometer. And this is actually shown as circle with G. This device. This is actual device which is used as a current measuring or a voltage measuring device. But you know what is the problem with a galvanometer? Can anybody tell me what is the problem of a galvanometer? So we change it into an ammeter.
Mm,
What do you think will be the problem of that?
are the readings too small?
Yes, that's the point. Actually, it is so sensitive. What is meant by sensitive? If very small amount of current or voltage passes it through, it will give you, because it has a needle, it will show full scale deflection on a very small scale. Now, my point is, if it's shown a full scale deflection on a very small value, how can you measure the big values? Even very small values, it will show a full scale deflection all the time. So if it continuously shown a full scale deflection, it is impossible to use a galvanometer as a current measuring device. So what we do, we convert this galvanometer into an ammeter. So now, if somebody will ask you what is the basic current measuring device, that is basically galvanometer. But we cannot use it because it measures very, very minute or small value of current. Or you can say on a very small value, it will give you a full scale deflection. Full scale deflection means you will have a scale here and there is a needle. inside there is a full process which we not have to discuss it. It gives you a full scale deflection. Your needle will go to the end of the scale. So how can you measure a current? So what we do, this is your galvanometer. We will place a very small resistance in parallel with this. Okay, I didn't tell you the parallel. So for the time being, leave it here. Just remind me when we will be doing series and parallel circuit, because that resistance should be connected in parallel with that. Okay, I will explain it later on. Just leave some pages, leave 1 or 2 pages, because I will let you know how the ammeter will be actually constructed and how the voltmeter will be constructed, because we didn't do the series parallel circuit. So, or did you know what is series parallel circuit?
Yes.
Okay, for the time being, just remember one thing at this point.
Yeah.
So what we do here, we just connect a small resistance and we give it a name called shunt. We connect this resistance in parallel with the galvanometer. This is your ammeter. You know, what is the thing now? What will be the difference here? If the current comes to this point, how many paths your currents will have once it reaches to this point?
Say again, how many what?
How many paths your current will have once your current will reach to this point?
Mm,
It will have 2 paths. Some of the current will go to the galvanometer and some of the current will go to the shunt. Am I right?
yes.
Now the shunt resistance is very small. Remember that when resistance goes small, current will increase. So it means that 99% of the current will pass through the shunt and only 10% of the current will pass through the galvanometer. So in that case, your galvanometer didn't show the full scale deflection, because very small amount of the current will pass through the galvanometer and that will be measured as a current. That is how your ammeter actually give you the reading. Nobody of you asked me a question which I was expecting from you. I'm saying 95% of the current is passed through the shunt and only 5% of the current passes through the galvanometer. It means galvanometer is only giving you the reading for 5% of the current.
Yeah.
So does it mean that the current you are measuring is not the right current? It is just the
It's not.
it is just the 5% of the current of the actual current you are measuring. What do you
Yeah.
say about it?
Yes.
It means the current you are actually getting by measuring ammeter is not the right measurement. What do you say about it?
It's not the right measurement, but then you said that is just 5%. So can't you just mathematically find the
Yeah, that's what
100%?
I see. That's what I am. Yeah, that's what you're absolutely right at this point. What we are doing is, for example, let's take it example of a car. Let's suppose there are 5 cars reaching to this point. This path is more less resistance and this path is having more resistance. You tell me, as a car driver, which path do you prefer? The shunt one or the galvanometer one?
The shunt.
Because it has less resistance, right? The point is,
Yes.
we calibrate the galvanometer. The word I am using is calibrate. Calibrate means we scale the things. We put the scale in that manner that, for example, if 4 cars are passing through the shunt and even 1 car is passing through the galvanometer, we mark the value of galvanometer as 5. That is our calculation. That is our calibration of the galvanometer, which we do in such a way that it will mark the current of the shunt as well as current from the galvanometer as well, mathematically, as I think Zoha said it.
Mm.
That is our mathematics technically. So basically, that is how our mathematician works on that, that we know that by calculation that this much current is passing through the shunt. So we calculated and we calibrate galvanometer in such a manner that even 5% current galvanometer will give us the 100% current value. So it's not a thing that galvanometer only shows us 5% of the reading. It will show us on the, scale full 100% reading. But definitely the current
Okay.
which is passing through the galvanometer will not be the full current, but only maybe 5 to 2 or 3% of the total current. But it will provide you the reading of full 100% of the current. Do you understand, guys?
Hmm.
Any
Yes.
problem? You, Alicia?
No, no, it's fine.
And one more thing. Once you do this ammeter, how do you connect this ammeter into the circuit? Series or parallel?
In
Series.
series.
Remember that to measure the current of a circuit, you always connect it in series. Yes. Okay? So,
It's to avoid this problem that we already discussed with the galvanometer.
yeah. What problem? Yes.
The
Yes.
problem of current going into two paths
Yeah.
so
But
that
no,
it gives an.
no, actually, the thing is, remember that we have to go through this problem anyway because galvanometer itself is giving very small reading and it will give you full scale reading on a very small values. So for that reason we connect a small resistance with a galvanometer in parallel, and that becomes your ammeter. All right, but once you are developed an ammeter, that ammeter will always connect it in series inside the circuit. Now when you connect this in series, forget about galvanometer and shunt as a separate resistor or a separate entity. Now these two will combine to give you ammeter, and you always connect them in series. All right.
So you're saying the ammeter is a galvanometer and this resistor in parallel.
No, no, I'm just saying this whole setup of galvanometer along with a parallel small resistance, this whole setup is technically ammeter.
Hmm.
Now, once it becomes an ammeter, we connect ammeter in series inside the circuit to actually measure the current. So once it become a ammeter, now you will not talk about galvanometer or shunt resistance separately. It is an ammeter which you connect in series to measure the current. Okay.
Okay.
Anybody have any question?
No, I don't have.
And Alicia, you?
No,
Now let's talk
no, it's
about
fine.
no problem. Now let's talk about voltmeter now. How do we actually design a voltmeter? The same resistor, same galvanometer, but this time we will connect a large resistor. We called it multiplier in series with the galvanometer, and this will be your voltmeter.
A multiplier is what does it do?
Multiplier means a high resistor, a very high resistor. In series, the voltage will be divided if you remember.
Yeah.
So if the resistance of a multiplier or resistance of this particular thing is very high, the most of the voltage will be dropped around this voltage, this particular resistance. So it means that voltage across the galvanometer will be very small or maybe approximately equal to zero on an ideal side. So it means again, if the voltage around the galvanometer will be very small, most of the voltage is around the multiplier. Again, the same thing. The voltmeter will be reading a very small reading. And again, mathematicians do the working with the calibration in such a way that let's suppose a voltage of 4 volt drop is around here, they will measure 5 volt altogether over here. So in that way, you will actually measuring the total voltage. Previously, it was a small resistance in a parallel so that most of the current is passing through the resistance. and very small current is passing through the galvanometer. That's what we required, because we want our scale to be as less as possible deflection. Because if it shows full scale deflection, then it's none of any use. You understand me?
Yes.
Actually, we want our deflection not to go full scale, because if it goes to full scale on a very small reading, on each and every reading, then it's useless. Because if deflection didn't show the full scale, then we can do some calibration, some working, some mathematical calculation, so that that value we can change into the actual voltage. All right.
All right.
So basically, how to convert voltmeter from galvanometer? You will simple connect a very high resistance, and we give it a name multiplier in series with the galvanometer. And once you actually develop a voltmeter here, that circuit needs to be connected in parallel to measure the voltage. So voltmeter is always connected in parallel to find the voltage across a specific component.
Component.
Right?
All right.
Ammeter will be connected in series to measure the current. Voltmeter will be connected in parallel to measure the voltage.
Okay.
Any questions related to this small topic of ammeter and voltmeter? Just quickly go through that.
No.
Just go through that
No.
quickly. Give you 2-3 minutes to go through it.
I have a question. You know, these like recorded lectures, where will they be?
You can get it through our coordinator, because I am recording it and I am uploading it on my, what do you call it, that drive, my drive. So you can get it through our, that coordinator whom you're talking about the classes. All right.
Yeah,
Inshallah,
yeah.
he be share with you, and you can get those there from there. No issues. Right.
So one more time, the
Okay.
galvan. So to measure the voltage, it's actually just a galvanometer. Uh, wait, no. I kind of don't remember what did you
Again.
discuss when you talked
I
about.
will. I will. Don't see, to convert your galvanometer into a voltmeter, you will connect a large resistance value. We called it multiplier in series with the galvanometer. All right. So galvanometer will be connected with a multiplier resistance, or you can say a very large resistance in series with galvanometer. Now, once it's connected in series with galvanometer, it will behave as a voltmeter now. Okay. Now, this small meter will be connected in parallel to measure the value of the voltage across a specific resistance or a specific battery.
Okay.
Okay. Understood?
Yes.
Now I am repeating two things. Listen to me very carefully, and if you want to note it, you can note it as well. I believe you already noted it, but just remember it what I am saying. To convert galvanometer into an ammeter, you will connect a very small resistance. What is the name of that resistance?
A very small resistance.
We called it shunt resistance, SHUNT, shunt. If you see the meaning of shunt, shunt means very small. So we connect a very small resistance, shunt resistance, in parallel with the galvanometer. And why do we connect it with parallel in the galvanometer? Because galvanometer is very sensitive. It will give you a full scale reading on a very small amount of current. So what do? We connect a very small resistance shunt in parallel with the galvanometer, so that most of the current will pass through the shunt, and very small amount of current will pass through the galvanometer. In such a way, galvanometer will not give you a full scale reading, and then we can measure that current. But how do we measure the full current value which is passing through the shunt and the galvanometer? That is what our calibration is all about. we calibrate the galvanometer in such a way that it will measure the current through the shunt as well as the current through the galvanometer. Okay, understood?
Yes.
Now, to measure the current of a circuit, we will connect that ammeter device into series inside the circuit so that it will measure the current. All right.
Mm.
Now, second thing was voltmeter. What I said about voltmeter is that to convert a galvanometer into a voltmeter, you will connect a multiplier, a large resistance, in series with the galvanometer. Okay. And we connect it in series. In the reason is because multiplier is a very high resistance and potential difference or voltage is directly proportional to the resistance value. If resistance is large, there will be more potential drop or high potential difference or very high voltage across the multiplier. So it means that most of the voltage drop is across the multiplier. Again, galvanometer will have a very small reading and it will not give you full scale deflection on that reading, right? So
Okay.
that small reading, and then we will again calibrate our galvanometer in such a way that it will give you a total reading or total voltage across the multiplier as well as total voltage across itself. Okay. When
Okay.
I'm continuously saying across this, it means that for voltage you must have 2 points. In current you don't need 2 points. You just need a line in which you fix the current. Here you need 2 points along which you want to find out the voltage. Like here, if this is the resistance, the voltage will be voltage across this resistance. Means you need this point and this point. Remember that in case of voltage, I will always use a word voltage across. Across means 2 point, within 2 point you can find out the voltage. Voltage across
Okay.
a galvanometer means you are finding the voltage across 2 points of a particular place. You cannot find the voltage of a circuit. Remember that. Voltage will be always across an equipment or two equipment or three equipment depending upon.
We
Word will
cannot find the
what you
voltage
say?
across the circuit. We cannot find the voltage across the circuit because it is different
No, no. We can
everywhere.
now the
Circuit.
word, see, now you use the word across. So now you can find out the voltage across complete resistance. You understand what I'm saying?
Mm.
When you say that voltage of the circuit, it's wrong. Voltage across the circuit is the actual word.
Okay.
When you say voltage of a circuit, it's wrong wording. As far as engineering or electricity is concerned, you should have said it that you must have voltage across 2 points around a circuit or across the circuit means there must be 2 points, one before starting the proper circuit like resistance or something and one after finishing the circuit. Inshallah, once we reach to series and parallel circuit, I will tell you in much more detail what exactly it is. All right.
Okay.
Yes, Alicia, any question?
No.
Okay. Now, once you understand that, at this point, there are a few more things which I have to tell you so that when we proceed further, you will understand this. There are three terms: short circuit, open circuit, and earthing. What do you think of short circuit? Any one of you?
Short circuit. I know the phrase, as in when something fuses.
No, it's nothing to do with fuse. It's everything to do with current and resistance.
Oh,
Because these words you may heard so many times in your house, but actually no one knows the actual meaning of it, but they just know. Okay, sometimes you heard the word from electrician who might fix your device. They say your device is shorted.
Yeah.
Now, what does it mean when he said your device is shorted? Alicia,
I
you?
always get confused.
Not sure.
Not sure? I want to put a heading of short circuit. Can I dictate because I'm tired of writing now? If I dictate you, will that be able you will be able to write it?
Yes.
Good. Put a heading short circuit. Now, first of all, let me give you an example. Okay. Let's suppose this is your microwave device and it has some resistance of, let's suppose, 20 ohms inside your microwave. Now, one thing which is very, very important is when temperature increases, you're continuously using it and temperature rises, what it affects on resistance? Resistance increases or resistance reduces?
Increases
Can you tell me the reason why the resistance increases?
because there's more collisions between the electrons when they're
Yeah.
flowing through the
This is very
this
simple. You're
microwave.
absolutely right. Absolutely right. Now, what is mean is when temperature rises, there will be more kinetic energy transferred to the particles of the resistant itself. They start more vibrant, and when they are more vibrant, they will collide with the current particles or current materials or current more frequently. So it means more collision with the current, such that in that way, resistance definitely increases. You're right. Done. So from now on, you will find out, you actually will know that if the temperature rises, resistance of the resistor also rises. Now at this point, but my point is, due to some reason, let's suppose when current passes through, instead of current, resistance rises due to some reason. If resistance reduces or it will be reduced from 20 ohms to, let's suppose, 5 ohms, what will happen?
Um, if resistance decreases from 20 to 5 ohms,
Yes.
when there is
So my point
current
is,
passing,
what happened to the current value? Will it be increased, same, or reduced?
it will it will increase.
Yes, it will increase. Now you're right. Now my question is, when somebody actually developed that microwave, right? He fixed a resistance of 20 ohms. It means that it must have supplied this much amount of current, which is this device is made of. Am I right? Hello.
Hmm?
What my point
Yes.
is, if you fix 20 ohms of resistance in the microwave somewhere, it means that there is some specific current value which is fixed for that particular place. Am I right? Because that
Yes.
resistance which you fixed over there, it means that their current value must be fixed as well. It it's another meaning is that if more than that current value is going on, it may not operate it will not it may not operate properly. Am I right?
Right.
My
Yeah.
question is, if the current increases, what do you expect? Will your microwave work properly or what happens?
It will work properly.
It will not work properly. For example, if in the microwave, the current microwave expect to have is 2 amperes. And here, if the resistance reduces, the current suddenly increases to 4 amperes. What do you think? It is used only for 2 amperes. Now 4 ampere current is coming in. What do you think? What happened to microwave? Yes,
It's it
it will
it's
burn.
not
It will burn. The wires of the microwave, or might be the circuit inside the microwave, will burn because it's only for 2 ampere current. Now suddenly the current is doubled. So it may not take this much amount of current, and due to this extra current, your device will be in danger or maybe catch fire very soon. For that reason, you must have to see through the electrician who will fix that. Otherwise, your device will be actually, you can say, will be in very much danger because current suddenly increase a lot. That's the reason this short circuit is very dangerous because short circuit means the resistance reduces and current increases. Do you understand what I'm?
Okay.
So this is dangerous.
Yes.
Everyone understand what is meant by short circuit?
Yeah.
Yes.
So basically, whenever now, if somebody said to you that your device is shorted, it means that due to some reason, the resistance of that particular device is reduced a lot. And when it reduces a lot, it start taking the current value more than the current it should have it. Now I give you a practical example for that. It's nothing to do with current, but you will understand. You know, you heard the word called tsunami.
Yes.
What is tsunami?
Yeah.
A very
Like
big
a
wave.
big wave.
Very big wave. Now my point is, listen to me very carefully. You know, these barrages and these dams and everything, they are created to store too much amount of water, right? So for small sort of floods and everything, we have our arrangements. But the point is, what if the wave is so big that it cannot be controlled or it cannot be taken up or cannot be stored? Then and only then your barrage and your, that all the arrangement went in vain. So same thing happened here. For some small values of the current, yes, it will control. But what if the current value is so high? Your resistance goes very small and your current goes very high. What will happen? It will damage your device. It's same like a tsunami
Mm.
because tsunami shouldn't be coming. Tsunami means too much heavy amount of wave. So I want you to write few lines for short circuit. Short circuit means short circuit means
Short
resistance
circuit means
means
the
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 resistance
resist.
the resistance of the circuit reduces. The resistance of the circuit reduces and current increases and current increases. After full stop, just continue. Ideally, ideally, resistance reduces to zero. Ideally, resistance reduces to zero and current increases to infinity. And current increases to infinity. Right?
Mm.
So I also give you the ideal condition as well, which normally won't there. But it actually means that resistance reduces and current increases. One more thing. When there is a current from a wire, can you tell me what is the voltage of that wire?
When there is a current, what?
When there is a current in the wire, or you can say there is a short circuit, what is the voltage of that wire?
No voltage.
No voltage. No voltage means what?
Um,
Zero
Meaning
voltage.
there is no flow. I mean,
No, no. Voltage is zero.
yeah.
Why? Because the whole wire which is short circuited, it's on the same potential. No potential difference.
Mm.
Understood?
Yes.
because these are the key things. That's the reason I'm telling you in this class, because in the next classes we will run, because these are the things which I had to tell you before we actually go into the deep of that. In the next classes, we will do VI characteristics of different appliances like diodes, lamps, and I think thermistor as well. Then we will jump to sequence and sorry, not sequence, series and parallel circuit calculations. And this is all what we have. Two things we left up with. And yes, internal resistance concept. All right.
Hmm.
But these are the things I had to tell you, because if I directly take you to that point, you will not be able to solve it. If you just go with the flow with me, hopefully there will not be any problem. All right. What
Right.
about open circuit? When the circuit is open, it's like this. Normally, for short circuit, you use a term like this. This is your short circuit. For example, if this is the battery, this is the signal or this is the sign of a short circuit. You show it with a straight line. As far as open circuit, you show it with this gap in that. First
Okay.
of all, what happened when there is an open circuit?
Uh, the circuit has broken.
Yes, one type is circuit is broken. The second thing is the switch is on. Sorry, switch is off. You know, switch is, you didn't turn it on. It was off. When it is off, it means it's an open switch. In
Hmm.
an open switch, what do you think? What will be the current value?
Zero.
0. And what will be the resistance value?
Uh, Full.
Maximum or very high.
Maximum.
In general, we can say that resistance is infinity. All right. So what is meant by open circuit? Open circuit means resistance is maximum. Resistance is maximum. Ideally infinity. And current is minimum. And current is minimum. And current is minimum or ideally 0. Okay.
Okay.
Now the last of this topic. Okay, one more thing. If the switch is open, what is the voltage across that open switch?
It's also maximum.
Yes, you're right now. Now you understand the thing. There is a small, I mean, relationship. Voltage is directly proportional to current when resistance is constant.
Hmm.
Voltage is directly proportional to resistance when current is constant. So here, your resistance is almost infinity. So voltage will be maximum. All right.
Okay.
Understood? Alicia, any questions? Hello? Alicia, you're there? Hello? I think she turned off the speaker. I don't know. Okay, now the last thing called earthing. What is meant by earthing?
Earthing is when I don't know how to explain it exactly, but I know we've done a Van de Graaff practical, and at the end of the practical, we were told that we needed to discharge ourselves so that we can go through. No, so that we can prevent ourselves from earthing,
You're
or it
right. That
is
you're right to some extent. But what exactly is earthing? I will explain it. What exactly happens? I will tell you. You know what happened? First of all, let's suppose you are using an iron here. I'll show it to you on a diagram here, or you can say on this particular diagram, so that you will going to understand that. Mm, earthing of an iron. Now check this out. This is your earthing. Now, what exactly is earthing? What is this earthing? Wait, it is not the one. This is normally an earthing if you see here. Now, what exactly is meant by that? All the devices, in every house, you have plugs in your house, right? Normally three-phase plug. Like it will have 3 pins or 2 pins,
hmm,
especially those devices which takes too much amount of current, like air condition and irons. One side of the pin is normally called as live wire. The other
live
one,
wire, earth wire, and
we
neutral
called
wire.
as neutral, and the third one is called earthing one.
Mm,
Now, what exactly happened? Now, my question is, for example, you have an iron. I'll show you the iron picture, then you will be in a better situation to understand that. Iron. This is your iron. Okay. Now, let's suppose you have an iron as this guy is ironing his clothes. What if this wire by any chance will be barbed and it is touching directly to the body of the iron? What will happen?
it becomes live.
It becomes live, or you can say there is an electric shock in the body of the iron as well. Am I right?
Right.
Now, point is, if you grab it while you are doing the ironing of the cloth, you will get the shock as well, right?
Yeah.
To save me from that electric shock, a sudden electric shock, we do earthing of the wire. So what happened? That sudden enhancement or sudden increase of current due to this, uh, you know, touching of the wire with the body of an iron, that third connection of the plug that takes that extra amount of current to the earth. In that way, you and me are saved and we will not get shock of the life. So
Hmm.
basically, earthing means extra amount of charges will be taken into the ground. All right. Now I want you to write that definition as well. Earthing of the equipment. Wait, earthing definition. This is very good definition which is written over here. I was there. So I just want you to. Now this is a good thing. The process of transferring the immediate discharge, the process of transferring the immediate discharge of the electric energy directly to the earth directly to the earth by the help of low resistance wire known as electric earthing. Low resistance wire called electric earthing, right? So basically, it says immediate. There is another word, we can also call it sudden increase or abrupt increase in the current. All right. So this is why we can reduce it or we can eradicate that extra amount of charges by simply taking it into the low resistance wire, which will take the current into the earth. And this way, our bodies, we are absolutely safe.
Okay. I remember learning this in GCSE.
Okay. So now, actually, we just reviewed few things from your GCSE, and definitely we add a few things into that. So, is it nice to have it? You understand everything?
Yes. Yes.
Yeah.
So,
Yeah.
now I want you to go through that because our next class will be when? Let's check it out. When is our next class, by the way? Can somebody tell me, please?
Tuesday.
Is it Tuesday? And that class will be very much informating because this is that one will be the pure difficult, things. Because in that one, what we will be doing VI characteristics of diode, VI characteristic of lamp, VI characteristic of thermistor and LDR, right? We will discuss in detail what is VI characteristics of these devices, and we will have a chance to understand the things about internal resistance of the battery as well. Then we will do certain numerical based on the internal resistance as well. And in the end, we will go for the series and parallel circuit calculations and finding the current and that what you call voltages as well. Once we finish with that, we will jump to wave and sound. All right.
Okay.
But so how long
One.
will it take to finish the electricity? Like,
The thing is, it's not under in my hand. If you understand the things fastly, we can do it
oh,
in
okay.
maybe in 2 or 3 sessions. If it takes longer, it's because of you. For me, I can finish this topic
Yeah.
in one class even. You know that as a teacher, for me,
Yeah.
it's not difficult. Do you understand me? But the point is, if a student didn't understand, then it's no use. What do you say?
Yeah. Yeah.
Yeah.
Right? Like, the way I am taking you, now you also start memorizing that few of them, few of things, or maybe everything. But if I suddenly take you to the actual, more complicated things which are in our course, you be just said, "Oh my God, what is difficulty? This is so difficult. I can't do that." That is the way of a teacher. How teacher takes you because you are the
So,
friends of Mahnur. Yeah, you can ask her
Yeah.
that how I took her to that point where, hope there, mashallah, she is at the moment.
Yeah.
okay. So
Okay.
will we be able to also solve questions with you?
Yeah, yeah, definitely. I'll be giving you questions and I will be providing you questions as well. First, I will solve the
Okay.
question with you, then I will give you question to solve. Don't worry about this. That's my way. That's I do.
Okay.
Okay. What did, by the way, when you ask Manur, what did she told? What did she tell you about myself, about for me,
They said you are nice,
and how do
and
you find it?
yeah, so far it's really good.
Yeah. Yeah.
Yes, Alicia, for you.
Yeah. Same.
That's great. Okay. Then, inshallah, see you in on Tuesday with again 2 hour session and be ready for that. What I want you to go through, please go through whatever we studied in this session. And also, if it's possible for you, go through the VI characteristics of diode, LEMP, and LDRs. We will discuss them in very much detail. And the third important thing is that I am uploading these lectures in my drive. So you can contact our coordinator if you want that videos to go through them again. I will give them names, right? Like today, whatever we done, I will give it a name, electricity basics. So you can go through this.
Okay.
It will give you all the details relating very much basic. What is short circuit, open circuit, what is resistance, what is voltage. So if somebody of you wants to go through that, you can have it. But for that reason, you have to ask our coordinator. All right?
Okay.
Okay.
Okay, see you on Tuesday then, hopefully. Bye. Take
Okay.
care.
Bye
Bye.
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 Bye.